In this video, we'll discuss the root test, which is similar to the ratio test, but is for series where maybe the ratio test doesn't apply. Okay, so typically you want to use the root test in the series where the terms contain the index k in both the base and the exponent. So the way the root test works is the following. So you do that. So suppose you have a series with non-negative terms. And then you compute the following limit. So you compute the limit as k goes to infinity of the kth root of the terms, or you can write it in exponential form as the term raised to the 1 over k power. So we'll let the value of this limit be rho. So this is the Greek letter rho. And then if it satisfies the following conditions, then you can tell whether it converges or diverges. Okay, so the conditions are the same as for the ratio test. So the difference is the limit that you're computing, which will be, again, be useful for these kinds of series. So let's look at an example. This is where you have the series, sum k equals 1 to infinity of k plus 1 over 2k raised to the kth power. Okay, so because in the series the k appears in the base for each term, and then also in the exponent, using the ratio test might be somewhat complicated. So we're going to use the root test, and we'll see that it's a simple computation. So in this series, AK is k plus 1 over 2k raised to the kth power. So we're interested in raising AK to the 1 over kth power. So then it will be k plus 1 over 2k, the kth power, to the 1 over k. And then the rules of exponents say that k times 1 over k is equal to 1, so those cancel out. And so this is just k plus 1 over 2k. So now, if we compute the limit as k goes to infinity, k plus 1 over 2k, and applying L'Hopital's rule, you'll see that this is equal to 1/2, which is less than 1, and so this series converges. Okay, so let's take a look at another example. So suppose I have the sum k equals 1 to infinity of 1 plus 3 over k raised to the k squared power. Okay, so again, here there's an expression involving k in the base and another expression involving k in the exponent. And so again, using the ratio test, this might be somewhat complicated, but we'll see that the root test is simpler. So a sub k is equal to this expression here. So then if I raise it to the 1 over k power, you get 1 plus 3 over k to the k squared to the 1 over k power. So we first simplify the exponent by multiplying. So this is equal to 1 plus 3 over k. So k squared divided by k is just k. And so now we compute the limit. The limit as k goes to infinity of ak to the 1 over k, which is this expression here. So as k goes to infinity, this goes to 1 and this goes to infinity. So this is of the form 1 to the infinity. So you have to use L'Hopital's rule to simplify this limit. So again, I'm going to skip the computation. So we've done several of these before. You'll see that this is e to the third power, which is bigger than 1. So according to the ratio of the root test, because this is bigger than 1, the series diverges.